Welcome everybody. In this particular video, I would be giving you the calculus roadmap to machine learning. Now, one of the reasons I'm making this is to bring about the awareness for the student community, irrespective of the age that you are. You might be 20, 30, 40, 50, 60, or even 70, or even above that. It doesn't matter. All that matters is if you know what to do and how to do. That alone is basically counting now. Now, you have to know that in the bygone years of the world civilization, there was this age. This is the Iron Age. During the Iron Age, the most important person was the blacksmith. Now, these people were treated more precious than gold. So if a person is a blacksmith, the king would take this person and he would house him in a special place and give him everything that he or she, or in fact he wants. Blacksmiths. Okay, so these people were very treasured because of the fact that they had that skill to make the iron to dance to their tunes. Right? So that is the Iron Age. Then came the scribes. Okay, so this is a different age altogether, where people who know how to write, people who know how to represent the train of thought were treated like gold. So the world is actually going through different phases. Now in this phase, we call this age to be as the digital age, and the changes are enormous. So the point what I'm trying to tell you here is, you are considered to be learned only if you know how to handle this digital age. In other words, how to communicate with machines. So machine learning, whether we like it or not, has become an all-important challenge to people. Or in other words, I should say, to be in the race, you need to know how to communicate with machines, how to use machines, and majority of the jobs will only be found in this area, because this is how the world is heading towards. You might look up to various researches published by people, you will understand what they are talking about, or even you can listen to discourses. Okay, so having mentioned that, what I want to give you is, I want to give you this calculus roadmap which will make you versatile. We are talking about calculus. The first and foremost thing that you should be solid is what is called as chain rule. And you need to understand and apply the concept of derivatives. Number two, when we come to topics, first and foremost thing, you have to be very much familiar with differential calculus. Now calculus is divided into two parts. One is differential calculus, the other is integral calculus. So in the differential calculus, you should know how functions change of functions over time. Right? This is very important. So this is critical. And also the application side, you will have to know how differential calculus, specifically derivatives, are applied to solve application oriented problems. At the end of the day, it's all about solving problems, right? So number three, as I mentioned to you, now comes the integral calculus. In integral calculus, you should be really good in integration. Specifically, why do we focus on integration? Because if you are given a Gaussian distribution and if they are asking you to find the cumulative value, you have to resort to integration. Without integration, how are you going to calculate? Even if you are going to be utilizing softwares, you should double check the value given by softwares. You cannot simply take the values given by a software, right? Because softwares, when they create softwares, they have the element of what is called as human induced errors and machine induced errors. Of course, there are other different types of errors that are there. So to be on the safe side, you have to have the knowledge of integration. Otherwise, it doesn't serve the purpose. So in integrations, again, you need to focus on application and different techniques, right? Because integration, when we talk, the moment we say integration, it's accumulation. And you also have to know how to calculate the area under the curve and the related applications, right? So when you go into area under the curve, you can see the applications that have been featured there. So number 4, this is also important. You have to know about gradient of a vector function. This is critical. So this involves understanding gradients, which are vectors storing partial derivatives of multivariable functions. So this will involve understanding gradients which are vectors storing partial derivatives of multivariate functions. Number 5, you need to know how to handle the Jacobian. Okay, so when we talk about Jacobian, we are talking about transformations and optimization. Okay, because optimization is an integral part of machine learning. Now after this, you need to know the term what is called as back propagation. Now this is very crucial for understanding how machine learning models learn and adjust their parameters. So this is crucial to understand machines, understand the learning curve that machines pursue, how they alter themselves because of the requirements. And of course, I've just mentioned to you optimization. Optimization is very important. So this is key for algorithms that seek to minimize, key to algorithms that seek to minimize and maximize functions based on the requirements. Okay, of course this is in perspective of involving machine learning models. Okay, so I have given you 7. Let me move on to the next page. So number 8, this is also critical. Number 8 would be support vector machine. You need to know what is this. So this is nothing but you create an algorithm. Okay, so we create an algorithm that has the ability to understand calculus concepts. Now, broadly speaking, okay, so I have given you the important concepts that you will have to familiarize with. Now, broadly speaking, if you take calculus, as I mentioned to you, they fall into 2 groups. One is differential calculus, other is integral calculus. Now in differential calculus, all of the topics that deal with differentiation, that deal with rate of change, that deal with gradients and partial derivatives, they all are important. So when you talk about differential calculus, and as I mentioned to you, integral calculus, you should be well versed in all types of integration, right? Now, why do I say all types of integration? You never know what you need. So having mentioned that, these two are the heartbeats. Now you should also be aware of vector calculus. That is critical. And there is also what is called as matrix calculus. Okay, so whatever I have mentioned, they cover the 7 items that I mentioned. If you are well versed in all this when it comes to calculus, then you can be assured that you are the man of the show. That is the way I can say, because this will cover everything that we need with regard to machines. So having mentioned you that all important information, I think this is a good place for me to stop. Now what you can do is, if you have any important terminologies that you don't understand, or you have a challenge on that particular term, connecting calculus, if it involves vector calculus or matrix calculus or differential calculus or integral calculus, please put your question there. I will try my best of answering it promptly. So thank you everybody. Until we meet again, enjoy.